Hi guys, this is Mrs. Homer, and today we're going to be talking about population growth graphs. So the first type of growth graph we're going to talk about is exponential growth. Exponential growth happens when a population grows very quickly. So you might see a slow begin or a slow start to this growth, but as the population becomes larger, it goes faster and faster. And so you quickly see it jump up in this J type of shape. So sometimes we call this a J graph. Now, why do we grow exponentially? Well, a population will grow exponentially when it has plenty of resources. So unlimited resources like space and food, it has no predators, it has no disease. So it has everything it needs, an ideal set of conditions, and it can grow and grow and grow unchecked. So this could occur maybe when a population first moves into an area or after a natural disaster. So you would see a population kind of come in and then boom, kind of grow out of control. Now, let's take a look at this group of seals. We have their population growth on this graph here, and you can see in the beginning that there is this exponential growth part right here, the slag, and then this kind of J shape, but it does seem to kind of steadily kind of flatten out there at the end, right? Or something's stopping it from growing out of control. And so what keeps the number of seals from going up even more? And that's things like food, water, space, resources, and disease. So think about it. As the population gets larger, there's a limited amount of food. So they might not all be able to get the food that they need to reproduce or to survive into the next generation. And so these things are called limiting factors, things that slow the growth of that population and stop it from getting exponentially out of control. So there's lots of examples of limiting factors. Things like competition between species, just resources in general, how much food I have, how much space I have, how much water or sunlight, how many dissolved nutrients, even things like natural disasters and human impacts like pollution and hunting can slow the growth of a population and keep it from growing out of control. Limiting factors can be both biotic and abiotic. So there are living things that control other living things like predators and disease, and there's non-living things like pollution and temperature that control population. But altogether, what happens is our exponential growth is slowed by limiting factor, and it turns into what we call logistic growth. So logistic growth might look exponential at first. So in the beginning, you can see that J curve right away. But we quickly see the limiting factors start to work on the population and start to slow the growth of that population down until it reaches what we call the carrying capacity. So your carrying capacity is how many organisms can live in that ecosystem based on the conditions that are set forth by the environment. So how much water is there? How much food is there? How many predators are there? And so the carrying capacity is basically what is the maximum population that can live in this environment successfully. And so we will see a population increase up to the carrying capacity and then begin to fluctuate around that carrying capacity. And so I really like this infographic. So you have the idea that we keep reproducing, but our population really doesn't go above that carrying capacity because there's so many things that are going on that stop our population from continuing to grow. Things like predators, hunting, disease, loss of habitat, human development, weather. And so we kind of stay consistently at that carrying capacity. Now, two important things to know about carrying capacity. First of all, we do not just go up there and stay right at that exact number. We will see natural fluctuations around the carrying capacity. And so if we overshoot it, we're going to drop down and then we'll overshoot again. And that's very natural to fluctuate around the carrying capacity. The second thing is because a carrying capacity is set by the environment, if the environment changes, then the carrying capacity can change as well. So for instance, let's say a food source all of a sudden kind of disappears from the environment. So some kind of disease wipes out a certain type of bush or a certain type of tree. Well, with the limited food, our new carrying capacity might be lower. So you can see in the second graph that the carrying capacity was pretty high, and then something caused it to drop to be lower. So maybe a change in the environment caused it to be a lot lower. All right, so again, logistic growth is when you have limiting factors that slow the growth and set your carrying capacity. So just take a few minutes to answer some questions about these graphs. All right, the third type of graph that we have is called a boom and bust cycle, and it really kind of combines the two graphs into one in a way. So a boom is when we go way above the carrying capacity, and a bust is when we rapidly come back down. So there's a J curve followed by the reverse of a J curve. And this boom and bust can happen due to big changes in the environment, like food shortages, natural disasters. But a lot of times we see these with predator and prey interactions. But again, we overshoot that carrying capacity, and then we have this period where we drop and we crash, and then we overshoot again and again. But most of the time we see this boom and bust in relationship to predator and prey relationships. So what happens is that the predator and the prey, because they're related to each other, as one population changes, it causes the other to change as a result. So for instance, let's look here. The lynx, the population goes down. That's my predator. Well, if there's not as many predators, the prey's like, woohoo! And so their population goes up. Well, as there's a lot more predators or prey around, the predators are like, woo! Now we can go up. And so you'll see the increase of the prey followed by the increase in the predator. Well, now there's a lot more predators eating my prey. So let's go down. The population drops, and then there's not as much food, so the predator drops. And so they'll continue to go up and down and fluctuate with each other, in this boom and bust cycle. Now, other things can play a role in here. So you can see the snowshoe hare got really high one year in its population. And that's probably because maybe there was really good food supply that year and a lot of plentiful space, and they were able to drive their population up really high. Or it might have gone down sharply one year, and that might be because a disease spread throughout the population. So the boom and bust definitely follows the predator and prey relationship, but other environmental factors will affect that relationship as well. All right, the last thing we need to talk about are the limiting factors themselves. So we've already talked about how limiting factors can be biotic, they can be abiotic, and that they slow the growth of a population. But there are two categories that we like to talk about that limiting factors fit into, and that's density dependent and density independent. So let's start with what is population density? That's how crowded your population is. So how many individuals are living in that particular area. So if you can imagine, you have a small room, you have 3 people in it. Oh, not very dense, but you put 30 people in a small room and you're all very close together, right? And so density dependent factors are going to become more prevalent, or they're going to affect the population more when the population is large. So for instance, crowding, that's not going to be a problem if your population is small. But when your population is large, all of a sudden that limiting factor starts to play a bigger role. And so as your population increases, this plays a larger role. And so these are things like competition. The bigger population, more competition. Disease, the bigger the population, the easier disease can go through it. Parasitism, stress, even the food supply and shelter, all of these are going to play a bigger role if the population is larger. So as the population grows, these things are going to start to slow the population. And these density dependent factors are really why we see this fluctuation around the carrying capacity and really why this slows down. So when the carrying capacity is reached, the population is going to fluctuate based on the density dependent factors and what they set the carrying capacity at. The other type of factor is called a density independent factor. And these factors are going to play a role no matter the size of the population. So, for instance, let's say we have a particularly cold winter. Well, the temperature, the fact that it's so low, will affect the population whether it's big or it's small. And so these are things that no matter what the size of the population, it's going to have the same effect on it, big or small. And so most of these are going to be natural disasters and human activities, like fires, storms, hurricanes, habitat destruction, pollution, things that they come in and they're like, it doesn't matter if you're a big population or a small population, it's going to affect you the same. So a density independent factor does not matter how big or small your population is. All right, that's all I have for the type of growth. Exponential, which is unlimited. Logistic, which is limited by limiting factors. Boom and bust, the relationship between predator and prey. And then again, the two types of limiting factors, density dependent and density independent. If you have any questions, feel free to contact me. And that's all I got for today.